Hello everyone, this is Mukha Krishna, roll number 20951A2130, branch Aeronautical Engineering. So today I want to discuss about the types of corrosion processes. Introduction. Corrosion is a natural process that converts a refined metal into a more chemically stable oxide. It is the gradual destruction of materials, usually a metal, by chemical or electrochemical reaction with their environment. Corrosion engineering is a field dedicated to controlling and preventing corrosion. Here is a diagram which tells about corrosion on exposed metal including a bolt and nut. So here I want to discuss about the topics: uniform corrosion, galvanic corrosion, crevice corrosion, pitting corrosion, other localized corrosion, selective leaching, dealloying, erosion corrosion. Uniform corrosion. This corrosion results from the continual shifting of anode and cathode regions of the surface of a metal in contact with the electrolyte and leads to a nearly uniform corrosive attack on the entire surface. An example of such corrosion is the rusting of steel plate in seawater. Galvanic corrosion. When two different metals are exposed to a corrosive environment, an electrical potential difference will exist. If the if the two metals are electrically connected, the more active metal will become the anode in the resulting galvanic cell, and its corrosion will be increased. An example of such a corrosion cell is the use of steel pools to hold copper plates together. Not all galvanic corrosion is detrimental. Zinc coated steel or galvanizing is used to protect steel, not because the steel is resistant to corrosion, but because the zinc, being anodic to the steel, corrodes preferentially. Hence, the steel is protected cathodically by making any exposed areas of steel into cathodes. Crevice corrosion. Crevice corrosion is a localized attack which occurs when crevices formed by lapped joints or areas of partial shielding are exposed to corrosive environments. Such resulting cells are referred to as concentration cells. Two common cases are oxygen cells and metal ion cells. Oxygen concentration cells occur when the shielded area becomes depleted in oxygen and the area acts as an anode relative to the oxide region. The corrosion becomes quite rapid because of the small shielded area as compared to the unshielded area. Do not get confused with the concentration polarization that we previously discussed. In the case of an oxygen cell, we have an oxygen gradient that forces the formation of the anode and cathodes with respect to the oxygen levels. This is uh, this is what will happen when the cathode and anode intersects. The initial driving force of such corrosion is the oxygen cell. The continued growth is fostered by the accumulation, often caused by the same factors that produced the low oxygen level of acidic hydrolyzed salts within the crevice. Alloys such as 18-8 stainless steels are subjected to oxygen cell crevice corrosion. The oxygen cell corrodes under the shielded area while the metal ion cell corrodes outside the area. As stated before, the initial driving force behind the corrosion is either the oxygen or the metal ion cell. Its continued growth is governed by the accumulation of corrosion products, calcareous deposits, and salts within the crevice. Pitting corrosion. Pitting is an extremely localized attack that eventually results in holes in the metal. It is one of the most destructive and insidious forms of corrosion. Basically, the alloys subject to pitting are those that rely on an oxide film for protection, such as stainless steels. The initiation of a pit can be a result of any of the following: a. Chemical attack such as ferrous chloride or aerated seawater on stainless steel. B. Mechanical attack such as an impact or scratching that removes small areas of the protective film. C. Crevice corrosion resulting from tiny deposits on the surface, especially in stagnant seawater. Some theorists state that pitting is just a special case of crevice corrosion. So this is the localized pitting of stainless steel. Other localized corrosion. In addition to the pitting and the crevice corrosion, the following are also localized corrosion. Faultless corrosion attack which occurs at the edge of the damp fabric. Deposition corrosion process in which a more noble metal deposits on a less noble metal and causes attack due to a bimetallic cell. It is common in copper aluminum systems. Film form corrosion localized attack of a metal surface beneath a coating due to the oxygen concentrated concentration cells. Fretting a rapid localized attack which occurs on mated surfaces under load when a small amount of slip is allowed to occur. It is often observed on bearings, shafts, and gears in vibrating machinery. Not only in mechanical damage of the surface possible, but the protective surface film of the metal is also removed. This is done hastens electrochemical corrosion processes. Conclusion: corrosion is the deterioration of a metal as a result of chemical reaction between a metal and its surroundings environment. There are also other corrosion processes which leads to rusting of iron and other metal. After a very careful investigation of the topic, I was led to the conclusion that provided iron, oxygen, and liquid water are brought together, chemical change takes place with the production of rust, even when every precaution has been taken to exclude even traces of carbonic acid, and that therefore some other explanations can be found for the fact that alcohol is inhibiting the rusting of iron. Thank you.